Let us discuss about maximum power transfer theorem. What is the statement of maximum power transfer theorem is the maximum power is transferred from source to load when the load resistance is equal to source resistance. That is the simple statement of maximum power transfer theorem. Let us discuss this maximum power transfer theorem in depth. How to derive the maximum power, how to convert the maximum power transfer to source to load. Power transfer theorem deals with the maximum power which is transferred from source to load in DC circuits. And the statement of maximum power transfer theorem is the maximum power is transferred from source to load when the load resistance is equal to internal resistance of the source. The simple statement is maximum power is transferred from source to load when load resistance is equal to internal resistance of source. Consider a circuit in the box. Whatever be the circuit we have, the total circuit is connected to a resistance RL. RL is known as load resistance. The total circuit will be converted into a Thevenin circuit. A Thevenin circuit, because Thevenin's theorem is important for maximum power transfer theorem or Norton's theorem. If you know Thevenin's theorem, maximum power transfer theorem is very simple. If you want to see the link in description, you can check how to solve Thevenin's theorem numerical problems. What is Thevenin's theorem? Whatever be the circuit, coming to maximum power transfer theorem, whatever be the circuit inside of the box, whatever be the circuit inside of the box, a load is connected to the circuit. The circuit may be voltage source, so many resistance, current sources, whatever it may be. The total circuit will be converted into one Thevenin's voltage and total resistance is converted into one R Thevenin and RL is connected. The language will be English and Telugu for this. For better understanding the Telugu students as well as other students, it is in English. Total circuit will be converted to one Thevenin's voltage, one Thevenin's resistance. How to solve Thevenin's theorem? How to do Thevenin's theorem? If you know, then you can understand easily. The entire circuit will be converted into one circuit, that is Thevenin's voltage, Thevenin's resistance, where Thevenin's resistance is nothing but internal resistance Ri. V Thevenin means total internal Thevenin's voltage. A RL will be connected. Why we are considering this is maximum power transfer theorem we are explaining now. Maximum power is transferred from source to load when load resistance is equal to source resistance. That is a statement. To prove that, we consider a circuit. The maximum power will be transferred to load when RL is made equal to Ri or R Thevenin. When RL is equal to R Thevenin, then maximum power will be transferred to load. Now entire circuit we converted into one Thevenin's voltage and R Thevenin and RL is connected. What is the current through in RL? Why we are calculating RL? Because power equal to VI. Power equal to VI in DC circuits. According to Ohm's law, V equal to IR. We can replace V equal to IR. I square R. You will have, if you replace IR, I into I square R. Power in DC circuits is given by I square RL. Power delivered to load is given by I square RL. For that purpose, we calculated IL. It is IL. IL equal to V by R. According to Ohm's law, R is RL plus RI. That is current through RL. Power delivered to load is I square RL. We substituted here. In place of IL, we substituted V by RL plus RI whole square RL. In place of I square R, we substituted current through RL. That make it as a equation number 1. For a given voltage source, V internal resistance will be constant. Suppose whatever be the voltage source we have, the internal resistance will be constant. Therefore, in this circuit, V and Ri is the constant. The only thing is load resistance can vary. Power delivered to load depends on the value of RL in order to find the values of RL for which the maximum power is delivered. If you want to maximum power delivered, differentiate the equation 1 with respect to RL and set the result equal to 0, then you will get maximum power will be transferred. How much power will be transferred when load resistance equal to source resistance you will get. In maximum power transfer theorem మనం ఏం చేస్తామంటే ఖచ్చితంగా మనం whatever be the circuit we are converting into Thevenin's equivalent circuit. థెవెనిన్స్ ఈక్వివలెంట్ సర్క్యూట్లో ఫామ్ చేసుకుంటాం. అంటే మనం ఇచ్చిన సర్క్యూట్ని థెవెనిన్స్ ఈక్వివలెంట్ సర్క్యూట్ ఎలా ఉంటుందో తెలుసు కదా, వి థెవెనిన్ ఇన్ సిరీస్ విత్ ఆర్ థెవెనిన్, అదే సర్క్యూట్ని ఇక్కడ ఫామ్ చేస్తాం. ఈ టెర్మినల్స్ మధ్యలో లోడ్ రెసిస్టెన్స్ కనెక్ట్ చేస్తాం టు ఫైండ్ మ్యాక్సిమం పవర్ ట్రాన్స్ఫర్ థియరం. టు ఫైండ్ మ్యాక్సిమం పవర్ డెలివర్డ్ టు లోడ్ వీఆర్ క్యాలిక్యులేటింగ్ థెవెనిన్స్ రెసిస్టెన్స్ అండ్ థెవెనిన్స్ రెసిస్టెన్స్ అండ్ థెవెనిన్స్ వోల్టేజ్ బోత్ వీఆర్ క్యాలిక్యులేటింగ్. And load resistance will be connected in series with Thevenin's resistance. అప్పుడు ఏమవుతుంది, ద కరెంట్ త్రో ఆర్ఎల్ వీ హ్యావ్ టు క్యాలిక్యులేట్ ఫస్ట్, ఎందుకంటే పవర్ ఈక్వల్ టు I²R కాబట్టి. అప్పుడు సబ్స్టిట్యూట్ చేస్తే ఐఎల్ ఈక్వల్ టు ఏమవుతుంది, ఈ సర్క్యూట్ నుంచి ఫ్రమ్ దిస్ సర్క్యూట్ కరెంట్ ఐఎల్ ఈక్వల్ టు V by RL plus RI ఫ్రమ్ దట్ సర్క్యూట్. ఈ సర్క్యూట్లో ఇంటర్నల్ రెసిస్టెన్స్ V, వోల్టేజ్ సోర్స్ అండ్ ఇంటర్నల్ రెసిస్టెన్స్ ఆఫ్ సర్క్యూట్ విల్ నాట్ బి ఆల్టర్డ్, అంటే చేంజ్ అవ్వదు. ఇక్కడ వేరియబుల్ టర్మ్ వచ్చి ఓన్లీ రో రెసిస్టెన్స్ కెన్ బి వేరియడ్. పవర్ డెలివర్డ్ టు లోడ్ డిపెండ్స్ ఆన్ ద వాల్యూ ఆఫ్ RL. ఇన్ ఆర్డర్ టు ఫైండ్ ద వాల్యూ ఆఫ్ RL ఫర్ విచ్ ద మ్యాక్సిమం పవర్ విల్ బి డెలివర్డ్, differentiate the equation 1 with respect to RL and set equal to 0. That is dP by dRL equal to d by dRL into P. P we substituted. Power delivered to load is P we substituted here. After that, if you derive this equation, then you will get the statement of maximum power transfer theorem. D by dRL V square RL by RL plus RI square equal to 0, that we can write. Now we are using U by V formula, differentiation U by V formula we are using. Now U differentiation of V square RL differentiation is 1 because variable in RL equal to 1. By differentiating that, RL plus RI square V square into 1 minus V square RL, differentiation of RL plus RI square, that is 2RL plus RI into 1 equal to 0. Now in both cases V square if you made common, RL plus RI whole square minus 2RL plus RI equal to 0. That equal to, if you send V square to this side it becomes 0, hence we can write RL plus RI square minus 2RL into RL plus RI equal to 0. RL plus RI, we can write RL plus RI into RL plus RI minus 2RL RL plus RI equal to 0. From that we can write RL plus RI into RL plus RI minus 2RL equal to 0. We are making common is RL plus RI. If you made common, then we can write RL plus RI minus 2RL equal to 0. Now if you send this side into 0 side, RHS side, then you can write this equation. You can write this equation, RL plus RI minus 2RL equal to 0. From that, RI minus RL equal to 0. 2RL minus RL is minus RL, that is RI minus RL equal to 0 you will get. From this equation RL equal to RI. This is the required statement. The load resistance RL equal to internal resistance of the source, then maximum power will be transferred. Thus for maximum power transfer, the load resistance must be equal to internal resistance of the source. Thus the theorem is proved. Simply, what is Thevenin's theorem? If you know the maximum power transfer to load, we are converting into a Thevenin's equivalent voltage, equivalent resistance, after that load connected. After that, if you calculate power, then you will get RL equal to RI. This is the required condition statement. It is very important. If load resistance is equal to internal resistance of the source, then maximum power will be transferred. That is the theorem verified, and it is a proof of maximum power transfer theorem. If you substitute Ri equal to RL in equation 1, we get maximum power delivered to load, that is P max equal to V square RL by, if you substitute Ri equal to RL, 2 RL square, it is V square 4 RL you will get. This is the maximum power. What is the maximum power transferred is given by, if you know V and RL by calculating maximum power transfer theorem, then P max equal to V square by 4L. It is also important formula. V square by 4RL or Vs square by 4RL. Vs and V both are same. If you consider a graph, RL is taken on x-axis and power is taken on y-axis. The maximum power is delivered to load when RL equal to Ri. Maximum power obtained, it is the maximum peak point of power, the maximum power at RL equal to Ri. Let us consider an example to solve maximum power transfer theorem. If you know the statement, if you know derivation, if you solve this numerical problem, you will get clear idea about how to solve maximum power transfer theorem. Calculate the value of load resistance RL, to which maximum power may be transferred from the circuit 1. Determine also the value of maximum power. We have to calculate RL. At which value RL the maximum power will be transferred from the circuit. Entire circuit is 120 volts, 40 ohm, 60 ohm, 120 ohm. 3 resistances and 1 voltage source is there. From this voltage source and this circuit, it is a box circuit. Assume that it is in the box what we derived previously. For this, to connect what is the maximum power transfer theorem, RL equal to Ri. We have to calculate Ri. First we go for Thevenin's theorem, finding V Thevenin. First step is finding the Thevenin's theorem, finding the V Thevenin. To find V Thevenin, what we have to do is remove the RL. Remove the RL, A and B terminals. Between A and B, RL is there. We remove that. 120 volts, 40 ohm, 60 ohm, 20 ohm. V Thevenin is voltage at AB when RL is removed. V Thevenin. V Thevenin also is equal to voltage drop in 20 ohms resistance. Voltage drop equal to V equal to IR. Hence we have to calculate I into R. R is already known 20. I equal to V by R from the formula Ohm's law. Now V is given by 120 volts. 120 by, if you remove the RL, then 60 ohm resistance, there is no current flows through 60 ohm. Entire current will flows through 20 ohm because it is a closed path. Now voltage drop I equal to V by R, 120 by 40 plus 20. Current ఎంత పోతుంది 20 ohms లో, 120 by 40 plus 20. Total resistance is 40 plus 20. We are not considering 60 because there is no current enter because it is a open circuit. 120 by 60 is 2 amps. Therefore, voltage drop in 20 ohms is V Thevenin, that equal to IR. I is 2 calculated, 20 is the resistance already we have. 40 volts, V Thevenin is equal to 40 volts. Now, we are going for finding the internal resistance. To find internal resistance, we are replacing the voltage source with internal resistance. If there is no internal resistance, simply short circuit. That is finding the R Thevenin or Ri, internal resistance or R Thevenin. To find R Thevenin, what we have to do? To find Ri or RTh, voltage source will be short circuited. If we have voltage source have any internal resistance, ఒకవేళ voltage source కి internal resistance ఉంటే ఖచ్చితంగా internal resistance తో షార్ట్ చేయాలి. And RL is removed. Thevenin's theorem ఎలా చేసామో finding the Thevenin's resistance, similar way we are doing to find Ri or RTh, Thevenin's resistance. Now to find RTh we shorted V by short circuit on 40 ohm, 60 ohm and 20 ohm. A, B terminals are removed. The resistance, load resistance is removed. By seeing the terminals A and B, we are calculating equivalent resistance. We have to see from this side, A, B and D. A, B terminals. R Thevenin or R internal resistance is RL is removed and 120 volts is shorted. That is the main thing to find R Thevenin. If you remove like that, if you short R V, then if you see from A and B, from right hand side to left hand side, we have to see 60 ohm is in series with 40 ohm and 20 ohm resistance combination parallel. That is 40 ohm and 20 ohm in parallel. 40 ohm is in parallel with 20 ohm plus 60. The parallel combination is 40 into 20 by 40 plus 20. Equivalent resistance is 40 into 20 by 40 plus 20 plus 60 ohm. The total resistance becomes 73.33 ohm. That is the R Thevenin. Now we are drawing the equivalent circuit. R Thevenin is connected. Thevenin's voltage source already we calculate 40. R Thevenin is 73.33. Already we calculated Thevenin's voltage. R Thevenin we represented here. RL we have to calculate. What is maximum power transfer theorem? Maximum power will be transferred when Ri R Thevenin, also known as Ri, RL equal to 73.3 ohm. In place of RL we can substitute this, because that is the maximum power transfer theorem. In place of RL, simply substitute R Thevenin or Ri internal resistance. R Thevenin, Ri both are same. That we represented here. R Thevenin, Ri equal to 73.3 ohm. Simply we are substituting the resistance in terms of R Thevenin. RL equal to, therefore maximum power delivered to load when R Thevenin equal to RL. That is the theorem. Therefore RL equal to 73.33 ohm. That is the maximum power transfer theorem calculation. How to calculate RL? And what is the maximum power transfer to load is, already we substituted the equation V Thevenin square by 4RL. Substitute to all values, when you will get maximum power is 5.45 watts. How to solve this problem? First we consider Thevenin's theorem. By Thevenin's theorem we are finding V Thevenin. V Thevenin can be found by open circuiting the load resistance. We have to calculate what is the maximum power. V Thevenin we calculate 40 volts. After that we calculated Thevenin's resistance. We calculated 73.3 ohm. That we represented in the circuit. According to maximum power transfer theorem, RL equal to RTh or Ri internal resistance. Ri is nothing but Thevenin's resistance. We substituted. Now V Thevenin square by 4RL. 40 square by 4 into 73.33 gives 5.45 watts. That is the maximum power. Solve one numerical problem and comment in the comment box if you solve that problem. Then you will get clear idea. If you solve this numerical problem, the numerical problem is calculate the value of RL to get maximum power for this below circuit. What is the maximum power also? Similar to previous example, what I explained. Based on that, if you do and comment the answer, two answers. What is Ri, R10 Thevenin, and what is the maximum power? Pmax. Pmax equal to V square by 4RL. That we have to substitute. Comment the two answers. Then if you do the problem. This is about maximum power transfer theorem. Simply we can say that maximum power will be transferred from source to load when internal resistance of source equal to load resistance, or load resistance equal to source resistance, then only maximum power will be transferred. That with verification of proof also we derived, on numerical problem we derived, and solve this problem based on that, then you will get clear idea. For Thevenin's theorem, check the link in description. Thank you. What are the applications of maximum power transfer theorem? The load resistance must be equal to internal resistance of the source. That is the statement of maximum power transfer theorem. This condition is referred to as resistance matching. Resistance matching is important in communication and electronic circuits so as to obtain maximum output power even if the efficiency is poor.